Welcome to Across the Globe. Today we will learn about virtual environments in Python. Virtual environments in Python serve to establish separate, self-contained spaces for project work, ensuring streamlined management of dependencies and packages. By leveraging virtual environments, developers avoid conflicts arising from differing package versions across projects. For instance, consider a scenario where you are working on two Python projects, each requiring a distinct version of a particular package. Virtual environments afford the flexibility to isolate these project-specific dependencies, enabling seamless execution without interference from conflicting package versions. Through the venv module in Python, virtual environments are effortlessly created, empowering developers to efficiently organize and maintain project-specific dependencies. To create a virtual environment in Python, execute the command python venv mynv. Subsequently, a folder named mynv will be generated, encapsulating the virtual environment. For activation, on Windows systems, input mynv scripts activate, whereas on macOS Linux, the command varies to source mynv bins binge activate. This practice aids in isolating project-specific dependencies from your system, ensuring a streamlined and controlled development environment. For instance, when working on multiple Python projects with differing library versions, employing virtual environments enables distinct project configurations. In scenarios where Project A necessitates a specific version of a library, concurrent work on Project B with a different version is effortlessly managed without version conflicts. Different virtual environment setups facilitate streamlined project development, offering flexibility and organization to developers. To add packages to a virtual environment using pip, use the command pip install package name. Alternatively, you can generate a requirements.txt file with all dependencies by running pip freeze requirements.txt, and then install the dependencies by executing pip install -r requirements.txt. For example, if you want to include packages like Flask and requests in your virtual environment, you would use pip install Flask and pip install requests. Subsequently, to list these dependencies in a requirements.txt file, run pip freeze requirements.txt, and to install them from the file, use pip install -r requirements.txt. Separate virtual environments are essential for managing different project dependencies efficiently. In this case, with two projects necessitating different requests package versions, creating distinct virtual environments for each project is crucial. By isolating project-specific dependencies within these environments, conflicts between versions can be avoided and compatibility issues averted. This way, each project operates independently, ensuring stability and functionality. For instance, Project 1 might require requests version 2.0, while Project 2 may need requests version 3.0. With their respective virtual environments, each project can have its distinct requests version without any interference. This segregation facilitates smooth project development and maintenance, enhancing productivity and minimizing potential errors. To deactivate a virtual environment, use the command deactivate. Then, to delete the virtual environment, remove the folder where it is stored. It is crucial to deactivate the virtual environment before proceeding with deletion to prevent any active processes from being disrupted. For instance, in a scenario where a virtual environment named mynv is no longer needed, the user would deactivate it using deactivate and then remove the directory mynv. This proper sequence helps avoid any potential issues that may arise from active processes within the virtual environment during deletion. A virtual environment in Python is like having a separate workspace for each project you are working on. Just like how you store different tools and materials in separate drawers for different projects, a virtual environment in Python stores different libraries and dependencies for each project. By keeping your workspace organized, you can prevent different projects from interfering with each other, just like how a virtual environment prevents conflicting dependencies. If you need to switch between projects, you can easily switch between virtual environments to ensure that your code runs correctly without any conflicts. Overall, a virtual environment in Python helps to keep your projects separate and organized, allowing you to work more efficiently. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance, coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet above showcases the concept of virtual environments in Python. Virtual environments are isolated environments created to manage project-specific dependencies and libraries without affecting the system-wide Python installation. In the code, 1. The virtualenv package is installed to set up virtual environments. 2. Virtual environments are created for two projects, Project A and Project B, using virtualenv project env and virtualenv project benv. 3. The environments are activated using source project A env/bin activate and source project B env bin activate. 4. Project-specific libraries like NumPy, Pandas for Project A, and Matplotlib, scikit-learn for Project B are installed within their respective virtual environments. 5. The environments are deactivated using deactivate when work on the projects is completed. The analogy of having separate workspaces for different projects helps in understanding the concept of virtual environments. Just like physical workspaces keep project-specific tools organized and separate, virtual environments in Python isolate project dependencies and libraries, preventing conflicts between different projects. Real-world examples, applications of virtual environments in Python. 1. Web development. Different web projects require different versions of frameworks or libraries. Virtual environments ensure each project has its dependencies, avoiding version conflicts. 2. Data science. Various data analysis projects may rely on different versions of data science libraries. Virtual environments help keep dependencies isolated for each project. 3. Testing and debugging. Isolating the testing environment using virtual environments ensures that test environments are consistent and reproducible. 4. Collaboration. When collaborating on a project, virtual environments assist in ensuring that all team members are working with the same dependencies and versions. Virtual environments in Python provide a structured way to manage dependencies for different projects, similar to having distinct workspaces for various endeavors in the real world. Let's explore a couple of industrial applications that leverage virtual environments in Python. 1. Web development agencies. Web development agencies often work on multiple client projects simultaneously, each with its own set of dependencies and libraries. By utilizing virtual environments, these agencies can create isolated environments for each project, ensuring that dependencies do not conflict with one another. This segregation helps in maintaining project stability and allows developers to work on different projects without worrying about compatibility issues. 2. Data science teams. Data science projects frequently involve experimenting with various libraries and packages to analyze data and build models. Virtual environments enable data science teams to create isolated environments tailored to specific projects or experiments. This approach ensures that the dependencies for one project do not interfere with the requirements of another. Data scientists can easily switch between different virtual environments to work on diverse analytical tasks efficiently. Virtual environments in Python offer a pragmatic solution for managing project-specific dependencies in a structured and controlled manner, ultimately enhancing productivity and ensuring project integrity. Keep learning, stay curious, and I'll catch you in the next video.